Hello guys. On today's video, I'd like us to discuss the class test solution one. So, from the class test, the first question was saying that you all should classify the following differential equation by completing this table. So, they want you to complete it and tell us whether the differential equations that you are given are they ordinary or partial differential equation. Give the order and tell also whether it's linear or non-linear. So let's look at the first one. So on A, we have 3y into dy by dx to the power 4 minus 4 the derivative of y in respect to x equals sin x. So to answer this first part of the table, is this an ordinary differential equation or a partial differential equation? So we see that this is an ordinary differential equation. It's ODE. Otherwise, how do we differentiate between the two? When we see the notation dy by dx or y prime, or it can be y with a dot at the top like that. All of this will imply that we are dealing with ordinary differential equations. However, if you see something like this, let's say you have partial of f in respect to x, or maybe it can be anything, partial of y in respect to x. When you see something of this nature, then you know that you are dealing with partial differential equations. Okay, so um yeah, this one is an ordinary differential equation. Now, the second question says that we should give the order. So now what is the order of this differential equation? In order for us to identify the order, we look at the one that has the highest derivation. So we see that here is just first derivation, y prime. But however, this one is third derivation. That means this whole differential equation then becomes of order 3. Is the third order. Is the third order ordinary differential equation. For the last part, is it linear or non-linear? Remember the two conditions that you have to satisfy in order for you to tell whether something is linear or non-linear. If y and its derivative, I'm talking of y prime, y double prime, going on like that to the nth derivative, they must be of first degree. So that means they must be of the power of 1, all of them. And the other condition says that um, the coefficients must depend on what? They must depend on the independent variable. So in this case, when we have dy by dx, y is our dependent variable. This one is the dependent variable, then x is our independent variable. That implies that we want to check if ever y, this is y prime, we want to check if ever it is of the first power as well as y. In this case, there is no y anyway in our equation. However, we see that because of this 4 here, let me change the color of the pen so you can see. Because of this 4 here, the power of 4, we see that our y prime is to the power 4. Then this first condition is not satisfied. In order for it to be linear, both conditions must be satisfied. Then this, now we can conclude that it is therefore a non-linear differential equation. So it's non-linear. So we are done with the first one. Let's look at B. So on B, what is going on? On B, we are given that we have the third derivative of y in respect to t plus second derivative of x in respect to t equals t squared. So what is going on with this one? Is it an ordinary or a partial differential equation? Because of these notations that we are seeing here, is the notations that I stated there, that they will always give us an ordinary differential equation. So this one is still an ordinary differential equation like that. So is it first order, third order, or you know what is the order of this? So now we are going to again check the highest order. So the highest derivation here is the third derivative. Then this again makes it to be a third order. just like that. So it is just easy application that you have to keep in mind. Otherwise, let's look at the last part. Is it linear or non-linear? Let's check. Now, all the derivatives here, they are depending on t. They are depending on t. So we see that they are all of first degree. Okay, we have y prime of first degree and x, y triple prime of first degree and x double prime is also of first degree. And the coefficients are just constants. In this case, it implies this one now it becomes a linear ordinary differential equation. Then we are done just like that. So for C, what's happening at C? Let me just change a pen. I'll write down the question. It said that we have x dy minus 4y dx equals 0. And they further tell us with x as dependent variable. So in order for us to make x dependent variable, that means the x must be at the top. So from this differential equation that we are having here, we're gonna basically divide everything by dy. We want to make dy in this case to be independent. So if we divide everything by dy, our differential equation ends up something like x minus 4y dx over dy equals 0. So now we can go and check whether this is it an ordinary differential equation or is it a partial. So from the notation we see that it is basically an ordinary differential equation. So we are done for the first part. Now what is the order of this? So we see that it is we have first derivation. So that derivation tells us it's a first order differential equation. Now, the last part they were asking us about the linearity of the thing. So, is it linear or non-linear? Let's check what is going on with x prime and x. So we see that x here in this case, we are going to look at x instead of y. So x is of power 1, is of first degree, and also x prime is of first degree. The first condition is met. So the other condition that we have to pay attention to is that of our coefficients here. So the coefficients is depending on the independent variable. Remember, we agreed that our independent variable for this question now is y. So both conditions are satisfied for this differential equation. Therefore, it implies that it is a linear ordinary differential equation. So we are done for the first question that was on the class test. So let's check what was the next question. So I'll quickly just paste it here. So the second question was saying to us that we should write down any of that we should write down the equation of any third order linear ordinary differential equation. So here are the keywords. They want it to be a third order. That means we want to write something that is of y triple prime. So you can change around, you can play around with the notation, even if you write it as third derivative of y in respect to x like this, it's still the same thing. Or you can write y with three dots at the top like that. It's still this implies that it's still the third order. I mean, if it is the highest order into our differential equation, then we have to have something either like this or something like that or like that. Okay, so now let's see what else is the keyword there. The other keyword that we have is that it should be a linear ordinary differential equation. That means when you are writing it, you should be careful. Make sure that it is linear. So I can say maybe I have something like 1 minus x into the third derivative of y in respect to x plus y equals 0. So this is a third order linear differential equation. Okay, so you can have any one. So for those who were lost a bit on how to write something that is a third order linear differential equation, I mean the answer was basically right there in front of your eyes. You could have taken this one. You could have taken this one. Even this one, it's a linear third order differential equation. Like when we were doing B, we verified that. We verified that it is an ordinary differential equation of the third order, okay, and it is also linear. So the answer was just right there in front of your eyes. I mean, this was just free 1 mark, okay. So yeah, they said any, so you can pick and choose whichever one that comes into your mind. Okay, so that's all about that question. Let's look at the next one. So the next one, I'm just gonna quickly copy it down. So the next question was about verification of a solution. So they tell us that we should verify that x to the third, we have x to the power 3 plus 3x y square equals 1. Verify that it's an implicit solution to this differential equation. Okay, so our differential equation that we have is 2xy dy by dx plus x square plus y square equals 0. So now we can use implicit differentiation on this on this solution that we have here. So we put dx everywhere. So let's take d by dx of everything. So if we take d by dx of everything, remember from calculus 1 that when you are doing implicit differentiation in respect to x, that means where you are seeing y, you're gonna have to keep y prime. Okay, when you are deriving anything that is related to y, you have to keep y prime. So let's see, what is the derivative of x to the power 3? That is just x squared. We are done with the first term that was there. Then plus here we see that it is basically product of two functions 3x and y squared. That means we have to apply product rule. So applying product rule, we can say, okay, let's not mind this constant 3, we can keep it as it is. Then is x times y squared. Let's derive x and leave y squared. The derivation of x is just gonna be 1, so there we're gonna be left with y squared. Then plus now leaving x, we're gonna have x like that. Then derive y squared, we are going to get 2y. So we get 2y. But then what did I say? We say that if we're deriving y, then we have to keep y prime. So y prime is basically the same as dy by dx. If you don't want to write y prime, you can say dy by dx. It's just one and the same thing. And the derivation of a constant is 0. Okay, so yeah, it's like that. So now, if we divide everything by 3 here, if we divide everything by 3, we're going to end up with x squared plus y squared plus 2xy. Now I'm gonna change the notation of y prime to write as dy by dx. I mean, it's just one and the same thing after all. I haven't changed anything. So now pay attention. Look at the solution that I have right here. If we look at the solution that we are having, if we look at this solution that we are having here and look at our differential equation, it's just one and the same thing, isn't it? Yeah, it's just one and the same thing. Then this implies that therefore you can conclude that x squared plus y squared plus 2, I mean, no, this is the differential equation. I'm rewriting a wrong thing. I have to rewrite the solution that we had there. So what was it? It's x. It's supposed to be x. It's supposed to be x. Come on. It's supposed to be x to the third. What's happening? Oh, sorry about that. It's supposed to be x to the third plus 3x y square equals 1 is therefore the solution to the differential equation. You are done just like that. So just differentiating this yields back the differential equation. Then it shows that indeed it is a solution to that differential equation. Otherwise, maybe one will try to have dy by dx by itself, but then I mean that will just be a lot of extra work. And when you are writing a test, obviously it's a race against time. You don't want to be wasting time on things like that. So yeah, that's all about that question. Let's move on to the next one and see what was basically going on. What were we asked? um Question 4. So question 4 says that we should identify the largest interval, determine the largest interval on which root of 1 root of 1 minus y dy by dx is equals to root of 1 minus x squared. So when they are talking of this, when will it have a unique solution? So when they are talking of unique solution, before you do anything, you have to remember your cases that f of xy should be, it should be continuous. It should be continuous without your region R. Okay, so yeah, maybe if I just draw the region R, it can look something like this: A B C D. Let's say yeah, you have something like that, and this is your region R. So this is just going to be your region R, where maybe you have your point X naught, Y naught. So it has to be continuous within this region. Okay, this is your f of xy. Then another point that you have to keep in mind again is that the partial derivative of f in respect to y should also be continuous within the region. Within should be continuous within region R. Okay, so it should be continuous within that region R, like that. So for those of you who might not understand how do we get f of xy, f of xy is basically I'll just write here that if you have dy by dx equals a function f of xy, this is how you find f of xy. You just have to put dy by dx by itself. Once dy by dx is by itself, whatever function that is on your right, then that is your f of xy. So in this case they gave us root of 1 minus y dy by dx, which is equal to root of 1 minus x squared. Okay, so now using this, what are we gonna get? So we want to find what is our f of xy. That means we want to leave dy by dx by itself. We divide everything by root of 1 minus y. So we get dy by dx equals root of 1 minus x squared divided by root of 1 minus y, just like that. So this is therefore, let me just buffer it with a different color. This one right there is what we call our f of xy. Okay, so now we can check if ever our f of xy is continuous. Let's check. In order for our f of xy to be continuous, they're basically asking for the domain, isn't it? Yeah, so the domain of this, what is it going to be? We see that we have to strictly restrict 1 minus, we have to restrict 1 minus 1 to be greater than 0. Otherwise, if it is not greater than 0, then we are going to have something complex under the square root here. It's going to yield a complex solution, and we don't want that. So basically, y should be what? Should be less than 1. Okay, so everything less than 1, or one might write it as y is an element from negative infinity to 1, and we do not want to include that one. Okay, so if we include 1 here, we see that we're going to have 1 minus 1, then root of that is just going to be 0. And when we divide by 0, it's going to be an undefined function. So we don't want something like that. So yeah, this is the first domain that we get. However, we still have to account for our what you call for our numerator as well. What is happening there? We see that we can restrict it to say 1 minus x square must also be positive always. Okay, but then in this case, since we are not dividing by the thing, then we can say it can either be greater or equal to 0. Okay, it is not really that strict in this case. I mean, if it is if the numerator is equal to 0, then everything else become equal to 0, and at 0 is still continuous. The function is still continuous there. Okay, then basically, if you give it a thought, 1 minus x squared is just a parabola facing down. So if we're having a parabola facing down like this, we can say it's positive here, and then everything that is below there is negative. So let's say here we have our negative 1, and here we have our 1 like that. Okay, so for those of you who get confused with finding the domain of this type of function, so basically, where is this positive? Because greater than 0 means positive, so it's positive between x is basically positive between minus 1 and 1, and they are included just like that. Okay, or you can say x is an element of minus 1 and 1 with square brackets. Yeah, otherwise if you put round brackets like this, then it's gonna be wrong, because now you are saying that you cannot account for 1, and if you are saying that mathematically, and it becomes wrong. Okay, so yeah, um that is our domain for 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 our f of xy. So for our f of xy, this is what we have. This is what we have for our f of xy. Now let's move on to the next point. The next point tells us that we have to also account the partial derivative. It should be continuous. But partial derivative of what? Of f in respect to y. So if we know that our f is this function right here, then we want to take the partial derivative of that. Let's see. We know that our f of xy equals root of 1 minus x squared divided by root of 1 minus y. So this is our f of xy. Now we want to take the partial derivative of that in respect to y. So if we are taking partial derivative in respect to y, this is how you read it. Partial derivative of f in respect to y. Okay, that means every time when we take partial derivative of f in respect to y, you treat x as a constant. So you don't have to worry about x. You just treat it as a constant. So that means we are just gonna leave this the way it is. We are not gonna do anything to it. We are gonna leave it like that. We are only going to work on this part here, okay? Yeah. So that is the only part where we are going to derive our function. However, now if you know, just for you guys to just to add on to the information so you guys can know, I mean, maybe some of you already know about partial derivatives, but if you have something like partial derivative of f, instead now in respect to y, maybe you have in respect to x. Okay, then that means you are going to treat y as a constant. Okay, so yeah, that is one thing that I wanted to add for you guys. However, when you are finding unique solution, it is always partial derivative of f in respect to y. Okay, so yeah, now let's see what is going to be our partial derivative of x in respect to y. So this now is going to be 1 minus x squared divided by 2. It has to be negative. Okay, then uh then it becomes then it basically becomes 1 minus y to the power 3 over 2. Yeah, it's something like this. The derivation of 1 all over root of 1 minus y. I'm saying it's minus 1 all over 2 root of 1 root of 1 minus y all to the power 3. So this and this is just one and the same thing. I mean, I can rewrite it as what I got there. What I got there was just 1 over 2 root of, instead of root, I wrote the root as half. Remember, root can be written as a power of half. So I wrote it as power of half. I had 1 minus y to the power 3 over 2. Okay, so this and this is just one and the same thing. So for those of you who are confused as to how do we get the derivation to be like this, I would like to leave that as a homework for you to practice. I mean, we can rewrite this as something like, let me think about it. It's 1 minus y to the power minus 1 over 2. So now apply power rule to this, then check if ever you are gonna get your derivative as what I say it is right there. Okay, so yeah, that is all about the derivation of this thing. Now let's move on to check what is going on. Let's move on and check what is going on with our domain. So we have to check as well, uh, where is our partial derivative of f in respect to y continuous. So here it's y. Yeah, like that. Where is it continuous? So we see that um it's still 1 minus y must be greater than 0, then y must basically be less than 1, or one can say this is the same as y is an element of negative infinity to 1. We don't have to include 1 there because it's gonna bring something that is not nice. Then for the top part, we can still have the same argument: 1 minus x squared must be greater or equal to 0. Then that implies that we're going to end up having x being an element of minus 1 and 1 included, just like that. Okay, so it's giving us the same it's giving us the same domain. Okay, they are continuous at the same domain. So now let's go back to the question. I'm pretty sure now people might have forgotten what it was asking. It says that we should determine the largest interval I on which um the partial, I mean, root of 1 minus dy by dx is equals to root of 1 minus x squared at y00 will have a unique solution. Okay, so where will it have a unique solution? The largest interval. So if we try to sketch our unique solution that we are getting here, if we try to sketch this, let's see what is it gonna look like. If we try to sketch it, we see that y is anything from negative infinity from below here to 1. Where 1 is y, I mean, where y is 1, we can say maybe y1 is there. Okay, and then what about x? X is everything between minus 1 and 1. So here we can have solid lines like that because minus 1 and 1 are included. We can have solid lines like that. And at 1, we can have dotted lines like that. So this dotted lines is such that we show that 1 is not included. Y equals to 1 is not included. So we are having a unique solution in between here. Everything that is in between here is going to yield out a unique solution. Okay. So what is the largest interval? So this is the x-axis and that is our y-axis. So we see that the largest interval is basically from minus 1 to 1. So we can therefore say that I equals minus 1 and 1. Then you are done. Yeah, now let's look at the next question. Let me quickly put it up there. Yeah, this question, I had a lot of people saying that it was quite tricky, but then yeah, I think it was just a misunderstanding of the statement that you all got here. I mean, the scenario, it might have been a bit tricky when you all were going about it. So let's see what they say. They say that in MA, in MATA 2654 class, 114 students. So the class has a total of 114 students. So let S denote number of students, which 114. A rumor is spreading that practicing your mathematics is quite beneficial. And they say let ST be the number of students who have had the rumors at time T, when T measured in days. This rumor was initially The rumor was initially started by two very smart students. So that means at initial, when time was zero, two students started the rumor. Okay, so that is to say we have an initial condition at s of zero equals two. Okay, yeah, because they said that let st actually here instead of just s, we could have just said we having s of t. S of T denoting number of students. So the total of them is 114. So initially, when time was zero, we two students already had the room. Okay, let me erase that. It's not necessary since I already wrote it down here in form of an equation. Sharp. Then assume that the rate, so pay attention to one thing, guys. As I'm reading the statement, I'm writing down what it mathematically means. Okay, so yeah, let's continue. Assume that the rate of spread of this, so already I see that I have a rate. So when they talk of a rate, I'm already thinking ds by dt, or I can say s prime of t. Okay, so they are saying that this rate of spread of this rumor through the class is proportional. So when they're talking of proportionality, I'm thinking of my proportionality constant k. So I already say this is equal to k. I don't know what they're gonna say when they move further. It's proportional. They say it's proportional to the square root of number of students who have not had the rumors. Okay, so it's proportional to square root of number of students who have not had the rumors. So now I am puzzled of what I should put under the square root there. Okay. However, I know that the number of students who have had the rumors, total of them is 114. Okay. So if 114 students had the rumors, I mean, if we have 114 students in total, yeah, this is the total number of students in class. If we have 114 students in class, and now we want to find out of 114 students, how many did not hear the rumors? So we can subtract the number of students who did not hear the rumors. 114 minus s. Okay, so that will be the number of students. So this is number of students who have not heard the rumors. Okay, so it's like that. So we go and plug in here, since they said um this rumors Spread of these rumors through the class is proportional to square root of number of students who have not heard the rumors. Okay, so 114 minus s. It's like that. Okay, then yeah, this is all the information I have made from just reading this statement. Then now let's see. The question says that set up a first order initial value problem to the model to model the spread of the rumor. So now to answer that question, when they say they want a first order initial value problem, they're basically asking me to write them this. This is already the solution. Just from reading, I already have the answer to the first question. So I'm just gonna plug the S of t equals k root of 114 minus s. Okay, this is the differential equation. However, they are not asking for differential equation, but rather initial value problem. That means there has to be an initial condition. And the initial condition is when time was zero, only two students had the room. Okay, so over time, most students are gonna hear rumors. Yeah, just like that. So yeah, this is the solution to this question. So most people they were getting confused with this part where they say number of students. Where is it? This one. This rumor was initially started by two very smart learners. So people were saying 114 minus 2, then they get 112, then they go on and subtract this. Uh, they subtract s and say that this is number of students who have not had the room, and this is wrong. This is not the correct approach. Rather, this statement here is telling you of the initial condition. So that's why even on the question here they want an initial value problem. Okay, so yeah, hope you guys are not gonna fall for the same thing again. So um this was not all. I think there was part B of the question. Let's quickly see what part B was saying. So part B of the question was saying sketch the graph of S prime of t. So now they want us to sketch the graph. Okay. So let's see. So they want us to sketch that graph. So they want us to sketch the graph of this. So how can we quickly sketch that graph? I mean it's an easy graph, isn't it? If we think about it, it's basically not that deep. So let's have our XY plane like that. Okay. So we know we can first try and find where is it going to intercept and stuff like that. So let's first look for our y-intercept. It's easy to find y-intercept. So here it's going to be s, and this one is going to be s of t, or rather, I mean s prime of t, right? So if we are looking for y-intercept, that means we have to set s to be equal to 0. So if s is equal to 0, what are we gonna end up with? Okay, we're gonna end up having that s prime of t is equal to k times root of 114. So this is going to be our y-intercept. So we're gonna have it there. We have root of 114 times k. Okay, so this is where our graph is gonna cross the y-axis. So we have y-axis there, then x-axis there. I mean, it's labeled as already. There's no need for me to even put y there as well. Sorry about that. So yeah, now let's see, where is it crossing the s-axis? It's crossing it where y is 0. I mean, in this case, we are dealing with s of t. So if we plug 0 this side, what are we going to end up? We're going to end up with 0 equals k root of 114 minus s. Okay, so dividing both sides by k, we're just gonna remain with root of 114 minus s equals 0. Then basically s equals 114. So let's say maybe it's somewhere there we have 1. Let's say somewhere there we have 114, like that. So the other point is here. Okay, so now we are gonna have our graph going like that. It's a curve going like that. Yeah, so this is what you had to sketch as your solution. Let me try and make it look more like a sketch that is curving. Yeah, more likely something like this. Okay, so this is the graph that you are supposed to sketch there. Otherwise, it was not a difficult question. I mean, most people got lost from A. So if you were not able to find A, then finding the sketch of B was impossible. But then, yeah, I think you all will rectify your mistakes and you will perform better on what you call the next tutorial test. Let's see if there is more questions. That was the last question of the tutorial test. So this will be all for this video. Thank you guys for watching and stay tuned for more differential equation techniques and problems that will be solved on this channel. Yeah, please leave subscribe and the comment. You can comment below even if you have a question that you'd like me to help you with. And yeah, let's see each other on the next video. Thank you so much.